A smart drone launching device was created by Ukrainian experts and installed on the backs of freight trucks as regular wooden cabins. Although these movable containers appear to be straightforward agricultural shelters, they actually incorporate remote-controlled roof systems, battery charging stations, and reinforced constructions with hidden launch platforms. Once these mobile silos were ready, the design enabled drones to be launched either vertically or at an angle, depending on their type, and integrated signal shielding helped them evade Russian surveillance's early identification. The Ukrainian. When the time came, encrypted activation signals were sent remotely. The roofs of the containers slid open, and the drones lifted off, some vertically, others using ramps or other means. Intelligence officers, possibly with assistance from local sympathizers, moved them deep into Russian territory. The trucks were silently driven to pre-selected sites near key air bases, parked in areas like forests, farms, or industrial areas where they blended into the landscape. They remained dormant for days or even weeks with drones preloaded, charged, and waiting for the order to strike. Because the launch sites were only a few kilometers, or about 2 miles, from their targets, the drones were able to reach their targets quickly, giving Russian defenses little time to react. Operators used live video feeds to guide the drones in real time, guiding them precisely toward parked aircraft fuel depots and radar installations. Many of the drones carried high explosive or shape-charge warheads that were intended to pierce aircraft fuselages, light up fuel reserves, while some utilized delayed fuses to maximize damage after breaching their targets. Others exploded upon impact. In addition to being a tactical victory, the operation demonstrated the increasing sophistication of drone warfare and Ukraine's capacity to strike deep within Russian territory. In all, 117 drones were launched in a well-coordinated attack that targeted at least 5 major air bases, including strategic bombers and aircraft that Russia no longer manufactures, making their loss all the more significant. A huge explosion shook the Arctic city of Severorsk, which is home to Russia's largest fleet of nuclear submarines. Ukraine also targeted strategic nuclear bombers at the Bly Air Base in Siberia. Other important military installations were also attacked, including the Ivanovo Air Base northeast of Moscow and the Dagalivo Air Base south of the capital. The Alenia Gua naval installation in the Murman region, which stretches as far as Siberia, was also hit by Ukraine. The operation caused significant damage, allegedly damaging or blocking the 295 and 222 strategic bombers, which Russia regularly uses to launch cruise missile attacks deep into Ukrainian territory, as well as the A-50 airborne early warning and control aircraft, which are essential for coordinating Russian air operations and detecting incoming threats. According to Ukrainian sources, the strike marked a turning point not only in the conflict itself, but also in the evolution of drone warfare on the modern battlefield. The strike was significant. According to reports, around 40 aircraft were struck. Some were totally destroyed in the explosions, while others sustained serious damage that made them unusable for extended periods of time. According to certain accounts, Ukraine may have been utilizing electronic warfare-proof fiber optic control systems. A camera is jammed at the front of the drone, and an RPG warhead is placed just beneath it. The warhead is surrounded by 4 rotors and 2 batteries, but the drone also possesses to understand how Ukraine launched these FPV drones, let's look at how they are made. On the one hand, the carbon fiber frame provides a lightweight yet strong structure that is designed to withstand the stresses of high-speed flight and collisions. On the other hand, the added weight with a fiber optic reduces its flight time to just 15 to 20 minutes, and its range is limited to only 1 mile or less. All of this cutting-edge technology necessitates a central processor, or what can be thought of as the drone's brain. The thin motherboard placed here, as you can see, serves as the brain, managing all the flight operations. Propellers are strategically positioned with opposite angles to ensure smooth and balanced flight. This counter-rotation helps the drone maintain stability and agility during flight. As we move to the drone's back, we find the cables that link the motherboard to the power supply, which is supplied by the battery. The battery is one of the drone's heaviest parts because of its energy density. Depending on its size and capacity, it can power the drone for anywhere between 20 and 30 minutes. Next, let's move on to the propellers and motors, which also require power and precise guidelines for proper operation. They are connected by a number of cables that are exposed to reduce weight and transmit control signals from the flight controller. This ensures that the drone stays as light and efficient as possible. At the front of the drone is a camera that is connected to the motherboard and the radio receiver, allowing it to send live video footage back to the pilot. This SE allows the pilot to see the precise location of the drone in real time, providing vital visual information for navigation and target acquisition. But contemporary warfare has brought new difficulties. For example, Russian forces are using electronic warfare systems more and more, which interfere with communication and control by jamming radio signals between the drone and its pilot. As a result, the pilot can no longer see and control the drone, which can result in mission failure. To counter these tactics, the Ukrainians have devised a workable solution, which involves deploying an additional drone. By acting as a signal enhancer, this secondary drone helps to counteract the effects of the enemy's electronic warfare units by fortifying the connection between the primary drone and the pilot, guaranteeing a steady link even in the face of electronic interference. The pilot regains control and can continue to guide the drone toward its intended target with this improved connection, ensuring operational efficacy even in the face of enemy attempts to jam communications. Lastly, we have here at the bottom is the warhead. This specific weapon is a rocket-propelled grenade, or RPG in complete form. If we examine more closely, we can see the piezoelectric trigger within. This trigger mechanism, which is located inside the RPG warhead and has an air-filled cavity with a conical liner, may not work as planned if the drone is moving too slowly or if it collides with a solid object, such as a tank, without applying full force. In these situations, the piezoelectric trigger may not activate, so an additional trigger mechanism has been positioned in the front of the warhead to guarantee that it explodes upon impact, either manually by the operator or automatically. Let's take a closer look at this warhead. The piezoelectric trigger is located at the front. An air-fill cavity and a conical liner are located directly behind the poelectric trigger, a device that uses the poelectric effect to create a voltage when deformed. Its purpose is to measure changes in pressure, acceleration, temperature, strain, or force by converting these changes into an electrical charge. When the booster propels the rocket out of the tube, its fins open up to stabilize its flight path for its intended target. Recall the warhead or grenade we discussed earlier. This is how it works. It first hits the piezoelectric trigger, which activates the detonator. The warhead and this conical liner converge to create a jet of steel. Inverted, and this configuration is intended to create a high-velocity jet of heat that is meant to penetrate lightly armored vehicles, or in some cases can even damage a main battle tank. And heat prepared to pierce a vehicle or steel armor plate, Ukraine removed these strategic nuclear bombers because they have been wreaking havoc. Let's examine how they might operate. The drone can also be equipped with various types of ammunition. One option is the shotgun effect, where the blast scatters shrapnel over a wide area, increasing the chances of hitting enemy soldiers. This mechanism can be manually triggered by the operator, giving them more control and making a more significant impact on the battlefield. While the two-pole of 295 can be positioned as a command and control center and also strike less defended infrastructures like the usual communication towers, which slows down the enemy response in the battlefield. The 222 million can sweep in and target enemies using KH-22 or 32 long-range supersonic anti-shipping cruise missiles or the Kinzel specifically designed to engage U.S. Navy supercarriers. In Stage 1, the planes can cooperate as nuclear and attack aircraft. Lastly, the 2160 Blackjack, also known as the White Swan, would launch cruise missiles. The 2160 can open its weapon bay doors and release nuclear cruise missiles one after another. When dropped, these cruise missiles deploy their wings and fly towards their targets, creating a nuclear explosion upon impact. However, the aftermath of such an attack can cause a nuclear fallout when a nuclear weapon detonates dust mixed with other materials. Once within range, these missiles would travel low and slow under enemy radar to reach her targets. This tactic is typical for all bombers in a nuclear war scenario. Check out our original animated video on anti-aircraft guns like the M2 Browning and how to fire at an enemy aircraft and the Zu-23 and how to operate them. If this happens to explode in mid-air, it affects many people. This nuclear dust can spread throughout Europe, Russia, China, and even the rest of Asia.